Okay, these are final exam questions from 2020, 2021, and there are 20 marks from multiple choice, and we will do multiple choice questions. Now, if the events A and B are independent, okay, the keyword independent, the probability of A is equal to 0.4, and the probability of the complement of B, okay, so let's not forget this is the complement of B, okay, is equal to 0.3. Calculate P, the probability of A union B. Now, let's remember the addition rule here. The probability of A union B is equal to the probability of A plus the probability of B minus the probability of A and B, or A intersection B. Okay, now here, okay, the probability of A is given explicitly. This is 0.4. And when we look at here, the probability of B is not given, but instead we have the probability of the complement of B. So we know that the probability of B, the complement of B, is equal to 1 minus the probability of complement B. Now in this case, the probability of B, okay, the B can be found by this. 1 minus B is equal to 0.3. So if you solve it for probability of B, we'll get probability B as 0.7. So now you can write here 0.7. Now here comes the last thing. So what is this? PA intersection B. Here you can take this PA intersection B as PA and B. This is another way to say it, PA and B. Now, since they're independent, we use the multiplication rule for the independent, PA times PB. So in this case, the probability of A times probability of B is equal to 0.4 times 0.7. We already found it, which is 0.28. So in this case, we will subtract 0.28 from here. So if you do this calculation, the answer will give you C. Now you will see, okay, now I want to remind you the rules here. This rule, the main rule, then we have this rule about the complement, and we have this rule about the multiplication. So we use 3 rules, we combine 3 rules together, we get this one. We don't do it in every question, but you will decide which rules can be applied in that question. Find, okay, this is lecture, by the way, this is lecture 9 topic, so it's a good question combining almost all the rules here. Okay, they find the interquartile range for the following set. So let me tell you, what is IQR? Let's remember it. This is interquartile range. And interquartile range is the third quartile minus the first quartile. So this, the difference between the third quartile and the first quartile is called the interquartile range. Now, in order to do it, you have to first order the data. Okay, is it ordered 62, 63, 64, 64, 70, 72, 76, 77, 81, 82? Okay, it's ordered. So this is all ordered. This is fine. Now we want to find Q1 and Q3. Now, how do we find Q1 and Q3? First, you find the median, which is Q2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 10 here, the median is dividing, okay, since it's 10, we can divide it 5 here. So the median will be Q2 will be here. We can find it Q2, but it's not asking Q2, so we will not need Q2. But now we have 2 halves, one, the first half, the second half. Then we have to find the median of the first half. the median of the first half. Okay, since we have the odd numbers here, 5 numbers, so the number dividing them is 64 because there will be 2 here and 2 here, and this will become Q1, the median of the first half. And the median of the second half will be Q3. In this case, 2 here, 2 here, and in the middle we have Q3. So we got 77 Q3 minus Q1 64, and which gives us 13. And this is the answer here. Now let's look at this question. The frequency distribution of weights in kilogram of a group of students is given below. Weights in kilos, it's given this way. It's here, the groups are given here. There's a group frequency distribution. So the weights between 30 and 36, its frequency is 6. It means like 6 students are between 30 and 35, 13 students between 35 kilo and 40 kilo, and so on. Now it says find the boundaries, midpoint, and the relative frequency of the model class. So we have to know 4 things here. 1, model class. The model class is the class with the highest frequency. So here, these are the classes. These are the classes. Now the model class with the highest frequency is, okay, then what's the highest frequency? It's here. So this is the highest frequency. So then we can say 4045 is the model class. So in this case, this is the highest frequency. So then we have the model class. So it's asking the boundaries for the model, the boundaries, the midpoint, and the relative frequency of the model class. Now, okay, we know the model class now, and let's try to find the boundaries. Okay, let's start with the boundaries. Okay, the boundaries. So the boundaries, if they're here 40, 45, and these are integers, so the boundaries will be half more on the right side and half less on the left side. So it will be 39.5. 9. Oh, yeah, yes. And then the midpoint. So what's the midpoint? The midpoint is just, okay, we find the midpoint as, okay, we add them, we add the class limits, divide by 2. This will be just 85 over 2, which is 42.5. So then the midpoint is this, and these are the boundaries here, the boundaries. And the total, the relative frequency. The relative frequency is equal to the frequency of the class divided by the total frequency. Now we are interested in finding the relative frequency of the model class, so it will be 14 divided by the total. So the total is 6, 13, 24, it makes 33. With this 7, it will be total is 40. So you say it will be 40. So if you do this calculation, you will end up with 0.35. So altogether, the D, okay, the choice D has these numbers here. So the answer is D. How many possible outcomes are there when a die is rolled and a coin is tossed at the same time? So when a die is rolled, we have 6 outcomes. And when a coin is tossed at the same time, we have 2 outcomes, head or tail here, head or tail. And here we have 1, 2, 3, 4, 5, 6. We have 6 outcomes. But when we do it the same way, you can have 6 here from 2 here, but we will have multiplication here because one can have 1 head, 1 tail, 2 head, 2 tail. So for each number, there will be 2. So we find the total cases like by multiplying 6 and 2, which is 12. Now, the following table contains some information about the probability for X. X is the number of calls received for a call center in a day. What is the probability of receiving at most one call in a day? So here it's asking the probability, okay, the number of calls is X. It says receiving at most one call. So it means X is at most 1. So what does this mean? Okay, this means at most 1 means either X is equal to 0 or X equal to 1. So this corresponds to at most 1 means 0 or 1. Okay, now how can we find it? It's basically we look at the property for, the probability for this. This is beta and this is 0.1. So we can say this is beta plus 0.1. Okay, now this is not in the choices, but okay, but this is true. So is there any any other way to calculate this one? Okay, another way is, to find this one is just subtract probability of X equal to 2 and 3 from 1 so that you can find them, because we know all of them will make 1. So you can subtract these two and you will get this part. So another way is this, I said, so it will be 1 minus, what's the probability of this? 0.3, and the probability of 3 is equal to alpha, so it will be minus alpha. So this is 0.7 minus alpha. So here in the choices, we see 0.7 minus alpha here. So then we will choose this one. But if we had this one in the choices, it would be also true. They are both true, but if you don't have it in the choices, you can go with this one. An instructor wants to know what are the most three mistakes the students do in the exam by a graph. What type of graph is the most suitable for his goal? So the most three mistakes the students do in the exam. So it means like this guy will make a graph, and here we'll write the mistake 1 and mistake 2 and mistake 3. So we will write the mistakes here, and we will look at the frequencies here, right? This is how many students did it, So, but we want to see the most three. So the most means like the biggest one, then the small one, then the smaller one. So we want it to look like decreasing heights. Okay, like this one, then this one, and then this one, and then this one. So we want to see the most three. It has to go increasing. So that this is a frequency graph which has a decreasing behavior, and which is indeed, it's a Pareto chart. It's not histogram. We don't have decreasing. It doesn't have to be decreasing here. And it has numbers here in a histogram. And a pi is just a pi graph. And bar graph is, it doesn't have to be decreasing. So it doesn't have to be, so, but the Pareto charts is especially, it's a histogram which gives the increasing heights, increasing frequencies. A researcher wants to construct a frequency distribution of the ages of the IAU employees. What type of frequency distribution will he construct? So frequency distribution of the ages. So we'll write the ages here. And then we will look at the histogram here, maybe. Yes, histogram. Or histogram, or another graph like bar graph, maybe. What type of frequency distribution will he construct? Okay, so how many ages there are? There can be like 17 years old people, like 18 years old. If you write all these, there will be maybe 50 different ages here, and it's too much. Okay, so but we can. Okay, we can make them this way. Instead of writing here, how many for 17 we have this, how many 18, so the number of people here, the number of people in the university with this age here, age versus the frequency. So it will take a long time, 50 or 40. So it's better we make them groups here. So we can say it's from 15 to, let's say, 20, 22 to 25, 25 to 26, or okay, let's say 21, 25, and like 26, 30. So it goes like this, let's say. Now this type of thing is the group frequency. So because we are making groups. So if you have a large number of the variable, the value of the variable is too large here, we use the group frequency here, the grouped frequency distribution. The categorical one, the category we have to write here, the categories, not numbers. And relative frequency distribution is something else. It's not, it won't show the frequencies, it will show the percentages. This one will show the percentages here, not the frequencies. So the group, it's not the ungrouped, because in ungrouped you have to write 17, 18, 19, but you have to have like 40 different values. So this is not wise to do it. This is not good to do. A survey. Okay, let's look at 8. So use the following table to answer questions 8 and 9. A survey on which type of coronavirus vaccinations the students in IAU took is conducted. So the results are shown below in the table. Use this table to answer questions 8 and 9. So here are the male students, and 323 of them took AstraZeneca, 452 took Moderna, and 92 took Pfizer-BioNTech. And in female students, we have these numbers, and this row is giving you the totals of the vaccination types. And here, this part here, this column is giving you the total of the males and the total of the female. Now, let's answer the question. If one student is selected randomly, what is the probability that he is a male or took Pfizer? So when you choose, like, okay, we will say the student is a male here. Student is a male and took Pfizer. So there are two things here, male or took Pfizer. So the key thing here is the or. So when you see or, okay, let's remember the rule for or, A or B is equal to, so this is the addition rule, the probability of A plus the probability of B, and minus the probability of A and B. Now, male or Pfizer means the probability of male, the student is a male, minus, plus, sorry, the probability that he took Pfizer. I mean, the student took Pfizer. So when doing this, you don't assume it's the student is a male, okay? Pfizer minus the probability that the student is male and took Pfizer. Now, okay, let's do it. So what's the probability that the student is a male? The student is a male is, okay, it's 867 in total. And always we are choosing the students from the big total. This is total number, the total number of students 100,003. So the number of male students total is 867 divided by 1003 plus, okay, the probability that a student took Pfizer is the number of the total Pfizer, so 120. So here we don't check male or female, it says student took Pfizer, so 120 divided by 1003, and then minus male and Pfizer. Here we are looking at the males that, who took Pfizer, so it's 92 divided by 1003. So if you do this calculation with a calculator, you will get C. 9. If one student is selected randomly, what's the probability that the student is, okay, the student is male, okay, student who took AstraZeneca or Moderna. So we can write the question this way. What is the probability that the student is female, okay, and took AstraZeneca, and or we can say still female and took Moderna. We can write it this way. So here, since these, I mean, if someone took AstraZeneca, they will not take Moderna. So for this reason, these two are mutually exclusive. So we can write here this is female and AstraZeneca plus female and Moderna. Now, what's the probability that the student is female and took AstraZeneca? Female and AstraZeneca, 28. Okay, student has taken randomly from 100,000, I mean 1,003 students. And female and Moderna is 80. So then we will say it's plus 80 divided by 1,003. So we'll get this one. This will be C. It is known that 80% of students are female in a class, and 30% of female students got a GPA of at least 4.5. Find the probability that a randomly chosen student from the class will be a female with a GPA of at least 4.5. Okay. Now let's try to write this one. Now, okay. Let's write this one first. 80% of the students are female. So what's the probability that a female student, as when you choose a student, the student is a female? It's 80%. So it will be 0.8. Now, 30% of female students got at least 4.5. So this means here, so since we are restricting this 30% to female students, so we're saying 30% of female students. So if this is given to us, we can say here, this is the percentage of female students. So it means the conditional probability, you can take it as a conditional probability. So the female students, okay, who got GPA of at least 4.5? GPA 4.5. So this is the percentage or the probability that the student got got 4.5 at least GPA, given that student is female. So we can write this one 0.3. Now, what is it's asking? Find the probability that a chosen student, a randomly chosen student, will be a female with GPA at least 4.5. So we want a female student, and in this student, like she will have this property at the same time. She will have a GPA 4.5. So we can write this one as, okay, so if you remember the rule, A and B rule is for the conditional probability. I mean, you can write this this formula all the time for conditional or, I mean, independent or dependent. It will work anyway. So, and also you can write it this way. Now, I will write here, I'll write the second as the probability of female because I have female here, and there's this female is here, so I will write, okay, you know, you can choose which one is female, which one is male, which one is female, which one is GPA, but here I'm preferring this one to be female, so this one is female, And GPA 4.5 is A then. Okay, so I will write here the GPA 4.5 given that female. So it's like here B and A, and this is like A, B, B. So I'm using this rule here. Anyway, or the other one, it doesn't matter. So, okay, what would we say here? A, B. Okay, if it is A, B, then this is like A, B. Okay, it's okay. So also you can write this one, no problem. Okay, then since after you write this one, so do we have this one? Yeah, it's here, 0.3. And do you have this one, female, at 0.8. So then this will be 0.24. Now let's look at 11. What percentage of the data is between 100 and 140? Now asking the percentage here between 100 and 140. So don't look at these numbers. These numbers are just listing the values, okay, not the data here. Okay, now be careful about this. Here, this is a box plot. So the box plot is showing you the minimum. So the minimum value the data takes is 40. The maximum value the data takes 50, 150. And these points here is 90 and 100. And there's this 140. These are making Q1, quartile 1. This is quartile 2 and quartile 3. Now, so quartile 1 has, okay, up to quartile 1, we have 25% of the data. And here also, this 25% of the data is also squeezed in, between Q1 and Q2. Because there's always the data percentage between Q1 and Q2 is 25%, and Q2 to Q3, it's 25%. And Q3 to max, it's 25% because quartiles are dividing the data into 4 pieces. So here, what is the percentage of the data between 100 and 140? What is this percentage? So check this out. So we're asking what's the difference between Q3, the percentage of the values between Q3 and Q2. It's just 25%, so it has to be 25%. Now, let's look at here. The following table contains the probability distribution of the discrete random variable x, the number of orders received in a day. What is the standard deviation of x? So if you remember the standard deviation of x as a formula. So this formula is square root of the variation of x. So what is the variation? The standard deviation, the square root of the variation x is this, the expected value of x squared minus expected value of x squared. Now, this means, okay, so how do we find this one? Init, this is found by this, the sum of x squared times bx minus x times px. Now we will find these two things here, okay, and then we will take the square root of this. Okay, let's be careful. Now it's a horizontal. This is given horizontal, but I would like to write it not horizontal. Okay, this x values takes. Okay, I will say the probability of x, and also I will write here x squared. So maybe it's better we do it this way. X first, 0, 1, 2, 3. And then x squared is what? 0.25, 0.15, 0.4, and then 0.2. Sorry, these are not. These are not the x squares, definitely not, because these are 0, 1, and then 4 and 9 here. And then probabilities. The probability that e equal to 0, x equal to 0 is 0.25. This one 0.15, and this one 0.4, and then 0.2. Now we'll write this x times px, and this will be 0, and this will be 0.15, and this will be 0.8, and this will be 0.6. So when you add all these, you will get, okay, ex, so the sum of xpx will be equal to, what is this? This is 6.1, 1.4, 1.55. So the total is 1.55. So, and look at here, look at this now. We will do x squared px. Now x squared px is, you multiply these two now. It's 0 and 0.15. And then 4 times this, it's 1.6, and this one 9 times 0.8. When you add them, you will get x squared px sum as 3.55. This is 3.55. So now we have this one. It's 3.55. Now the next thing is we have to write them in here. Okay, we found this one. xpx is x squared px is 3.55. And then this one here, xpx squared, 1.5 squared. Okay, if you do it with a calculator, this will be equal to approximately 1.07. So this is the answer now. So this will be equal to this one. A multiple choice exam contains 3 questions with each with 2 choices. What is the probability that a student gets at least one correct answer just marking the choices without reading the questions? Here is a situation. So we have 3 questions and there are 2 choices. And each time, find the probability that we choose an answer is 1 over 2. We choose a correct answer is 1 over 2. Now, okay. Okay, so what we can do here is this. So these are the first question. I mean, you can do it in several ways. Okay, in several ways. This is the third question. We can have here, we can choose true or false, true or false, true or false. I mean, these are the possibilities. So in total, how many options we have? Like we have true, 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 or true, false, true, false, true, false. It's like head or tail, and we can write all of them here. True, 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 false, true, and then true, false, false, and then we can say here, what else? It's false, false, false. Okay, the best way is to write here T, 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 T. Okay, the best way here is, if you don't want to miss anything, you can make here T, F. Okay, the first one, and then second one is make it a 3 diagram, and it will not miss anything. So the third one is like T, F, T, F, and T, F, and TF. So you have in total, you have 1, 2, 3. So it goes like 8 choices here, 8. And it says at least one correct. So it means you have to have one true and one or more true. So you will count them here. So this is like T, 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 F, T, F, T, and T, F, F, and then F, T, T, then F, T, F, and F, F, T, and F, F, F. So these are all false here. And now we want the probability that one correct answer here, I mean at least one correct, so at least one true. At least one true is here we have 3, at least one. So at least one means like one and more, okay? So there will be like these here, we have all trues here, but not this one, there's no true here, so it has to be 7 or 8. Now, this is one way to do it, or the shortcut here, the shortcut is this. What is the probability? So the at least here, the probability at least one true means, okay, here, the probability that at least one true is equal to 1 minus, okay, what's the opposite of at least one true? It means the probability that no true. So it's no true. So it means, now in this case, it means 1 minus the probability that we have false, false, false. So what's the probability that false, false, false? It will be 3 false. The first one is false, the second one is false, and this will be like 1 over 2 times 1 over 2 times 1 over 2. So the probability 1 over 2 times 1 over 2 times 1 over 2. So it will be 1 over 8. Then we can write it here, what? 1 minus 1 over 8 to 7 over 8. So we got the same thing again. So we can use, I mean, the key thing is here, maybe, you can do it in another way, but the best way here is if you see it at least, think of its opposite or complement. So you can go from the opposite or complement. So what is D5 for the following data? For finding D5, first you have to order the data 3, 5, 8, 12, 15, 18. So we check the order. Okay, it's ordered, so this is good. Now, if you want to get the D5, what you do is D5 means decile, so it means 10 pieces. We want the fifth piece from 10 pieces. What you do is you count how many numbers, the numbers you want, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11? Okay, in total there are 11 numbers. So then you write 11 times D5, which is 5 over 10. So if it is D, so you have to take 10. So when you do this one, you got 5.5. So if it is a decimal number, so you round it up. When you round it up, you will get 6. So it means D5 is the 6th number here. When you order them, sixth number. So you see, let's look at here. It's 1, 2, 3, 4, 5, 6. So this will be 18 is D5. So it will be 18. In a certain hospital, the absences of 10 employees during the summer were investigated. The following information has been calculated. And the sum of xk's is 48. The sum of sub xk's squares are 318. The xk denotes the number of days on which the kth employee was absent. So these are the absence of the xk. It tells the absence of the number of days of absence of the kth employee. Find the standard deviation for the absences of 10 employees. Okay, now we are given 10 people and we want to find the standard deviation and especially standard deviation of the absences of 10 people. Now, standard deviation, sample standard deviation formula is this. It's equal to the square root of sample variance. So how can we get the sample variance? So we have to write the formula here. The formula is n times the sum of the squares minus the sum of the x's squared divided by n times n minus 1. So here n is the number of the employees, it's 10, and the rest is just, we will put them in the formula, and then we will find it. And 10 times, what is this? This is 318, and minus the sum of xk squared, so this is 48 squared, divided by n, which is 10 times n minus 1, it's 9. So we will do this calculation, and if we do this calculation, we will end up with 3.12. So you can use a calculator to do it. The distribution of test scores in STAT 101 are shown in the following polygon graph. So the cumulative and the relative frequency of the fourth class are respectively, okay, what? Now, the cumulative and frequency of fourth class. First, we have to find the fourth class. By the way, these are just the midpoints. Okay, these are the midpoints. And if it's a polygon graph, so these are the midpoints here. And for each midpoint, we have a frequency. For this one here, it's 0. And for this group here, we have the frequency 5. So this, okay, we don't start with the 0, 1 here, okay? And we start with the first one, and the second group is here, the third group, and the fourth group. So the fourth group is corresponding to the frequency here, 40. So, okay, now you can say the first group frequency is 5, and the second group is, you don't have to write the classes here, so okay, 10, and for this one, the third one, it's 30. This is the third class. The fourth class is said that is 40, and then the fifth class is this one here, fifth class. Its midpoint is this one, so it will be 15. And then, yeah, the last one is again 0. So if it is 0, we don't have to write it. So basically, what we want to do is find the cumulative frequency and the relative frequency. The cumulative frequency comes with, adding the frequencies here. So this is 5, this is 15. Each time you add, it's 45. So you add this to 5, and then you add this to 30, you got 45, and you add this one to 40, you will get 85. So this is where we stop because it's asking the fourth class. It's 85, so it's obviously this one. Now, and I want to show you the relative frequencies. To get the relative frequencies, you have to add all these numbers. When you add all these numbers, okay, this up to here it was 85, and plus 15, it will be 100. Okay, now the relative frequencies are calculated. Relative frequency, it's 5 divided by 100. You divide by total 10 divided by 100, and then 30 divided by 100, and 40 divided by 100. So this has to be the relative frequency for the fourth class, so it will be 0.4. Now, the following graph describes how 135 students come to school every day. So by walking, 40 of them, by school, 30 of them, bus, 35 of them, train, by train is 25 of them, car is 10. If this bar graph is converted to a pie graph, what will be the degree associated to the model graph of this bar graph? Now, in order to make the pie graph, so let's make a table here, table of the frequencies, and this is the type of transportation. This is walk. This is walk is 40, and then bicycle is 30, and bus is 35, and then train is 20, and okay, the car makes 20. So okay, 10. So when you do them as a pie graph, I mean pie chart, so you will have like the biggest one will be walk here, and then maybe bus here, and then there will be 3 more. So there will be like 5 here. Bus, the bicycle, and maybe train and car here. Anyway, this one, the model class here is with the highest frequency. This one is the class with highest frequency. So the highest frequency will be here is walking. Okay, so the question is, what is the degree here? So what is the degree of this? So if you want to do a pie chart here, the corresponding degree for this one will be 40 over the total here. The total is 135. We know it, times 360 degrees. So it will be corresponding angle or degree. So this will be, if you use a calculator, you will get this one, 106.7. If the variance for a data is 16, the coefficient variation is 8%. Then find the mean of the data. Now, what is coefficient of variation? Let's write it first. The coefficient of variation is calculated by this formula here. The formula is the standard deviation divided by the mean. Okay, and yeah, now it says the coefficient of variation is 8%. So 8% means 0.8. Oh, sorry, 0.08, which is equal to standard deviation, which is, okay, we don't know it yet, and the mean, okay. But what is given to us? This variance is given to us. So if the variance is 16, what can you say about standard deviation? The standard deviation then, square root of the variance, which is 16, right? So it will be 4. So it means we have this one then. 4 divided by the mean will be equal to 0.08. So what's the mean then? The mean will be here 4 divided by, okay, you can change them here. That will be 4 divided by 0.08, and this will be equal to 50. Now, which of the following frequency distributions is correct for the Augur graph given below? Okay, from which one we can have this graph? So this is the cumulative frequency distribution, cumulative frequency distribution. Now when we look at them, 28, 31.5, 28, 31.5, you can understand the first class is starting from here. This is standing for the first class, and each difference on the height is giving you the frequency of the class. So the height here is 2, the change is 2, so it will be here 2, and the 2 is correct. Now 2, I mean we have 3 options. Now when it comes to the other class, so you look at the difference between the previous class and this one here. And this difference is 4 minus 2, it's 2. So the difference here is 2. So for this reason, the second one will have 2 here. And we don't have here 2, we don't have here 2. So this is the only option, so we can say this is A. And if you want to go higher, so you write here, you look at this difference. Since it's cumulative, the frequencies are just the differences between the cumulative frequencies. Is 10 minus 4, it will be 6. And here, look at this height here. This height is 20 minus 10, it will be 10. So as you see, each height here will make a difference here. I mean, frequency. Yeah, this is the property of O'Keefe graph, which is cumulative distribution. Sample variance given the following information. So the sample variance formula is what? Okay, the sample variation formula with the frequencies here. This is the frequency here for each value. Now this will be f times x squared minus, okay, this is n times. So n is the sum of the frequencies. This is 15, okay. Now it will be 15, this is n, 15 times, or n times, let's say n times the sum of the frequencies, x squared, the sum of f times x squared minus f times x, the sum of the x values with the frequency, which multiplied with frequency squared, and then divided by n times n minus 1. So if you write this one, this is what? This is 4,000. This n is 15. 15 times 4,500 minus this one is this one. So it's 240 squared divided by n, which is 15 times 14. So this will be equal to, and with the with the help of calculator, you can see this is 47.142 or something like this. But here it's rounded up, I guess, or approximated. It's B. Which of the following measure of central tendency is least affected by outliers? So in order to see this, you can make an experiment. I mean, take an example here. Let's say we have numbers like 10, 11, 12, 13, 13, and then 13. And assume, okay, let's say here 9. And okay, now what is the mean of this? Okay, what is the mean? The mean is you will add all of them and you will get the average. So the mean is the average. Now, mean is 9 plus 10 plus 11 plus and up to 13, the last one, divided by 1, 2, 3, 4, 5, 6, 7, 7. The mid-range is 9 plus 13 over 2, which is 22 over 2, which is what? 11. Now, the median here is, if you look at here, the median is equal to this. The median is 12. And the mode is 13. Now, if the data has an outlier, so if we assume there's an outlier, let's say the outlier means like the very, very big value attached to the data, or a very, very low value. So, for example, when you put 1,000, what happens? So the new mean will be what you will add here 1,000 divided by 8, and you know this mean changes. This affected because this we have 1,000 here, and the mid-range will change. You know, this will change, so it's affected. Now the median will change, so it will go up to here. This will be 12.5. But when you look at the mode doesn't change. So the least affected is the mode. I mean, mostly these two are least affected, but the mode in general, the mode is the most, I mean, the least affected. So the mean, the mode will be the least affected by the outliers. So not the median. I mean, generally this question is asked um, which which of the following measure of tendencies, central tendency, measures of tendency and median mode given in the same choice, but it's mode. A jar contains 5 red marbles, 3 blue marbles, 2 white marbles, and 8. Okay. If 2 marbles are drawn from the jar with replacement, what is the probability that both marbles are the same color? So, both are the same color means we draw red, red, or blue, blue, or white, white. So the question is asking what is the probability that we choose an RR or blue, blue, or WW? Now, when you do this job, you see it's with replacement. If it is with replacement, all the drawings are independent. So then you can say, and one other thing is if you choose red, red, you cannot choose blue, blue, and they are mutually exclusive. So you cannot. I mean, you can use the addition rule as the probability of BB plus probability of RR plus probability of WW. And what's the probability of RR? So since these are independent, so you can write it like the probability R times probability R. Now this is probability B times probability B, and then probability W times probability W. So then this means, okay, I used the addition rule, then I'm writing multiplication rule because of the independency. What's the probability of getting a red marble? So red marble is like 5 out of, what's the total? It's 10. So it will be 5 out of 10 and 5 out of 10. And then blue, it's 3 over 10, 3 over 10. Because each time, like when you replace the balls, you will get 10 again. So W is like 2 over 10 times 2 over 10, which makes 0.5 squared, 0.3 squared, and 0.2 squared. So this will be the answer then. Which of the following is not a measure of variation? So a measure of variation means how the data is spread. So it's asking if you have the data, so you look at the mean is somewhere here, and when you put the points here, all the data, and so you are looking at how it's spread. The variation means how it goes, how it is spread, the data. So when you look at here, the variance is giving you how it's spread from the mean. Standard deviation the same way, it's the square root of the variation, and the coefficient of variation is standard deviation divided by the mean. So it's also look at the variability here. So these are all the measures of variation, but the correlation coefficient is not. Coefficient correlation is something about the xy's here. So this is these points are not the xy graphs. So these are just the x values. They're all put in here. So x values here, and these are the values. Okay, it's not xy. I mean, these are not the order pairs. They are different. So this is correlation coefficient. Now the distribution of stat 100 final exam scores is represented by the following box plot. What can be said about the skewness of the distribution of statistic 100 one final exam scores? Here, look at here. This is left tail here, left tail, and here there's left box, right box, and right tail, let's say, right tail, or left line on left box. So as you see here, the left box, the left line or left tail is bigger than right tail. And left box is bigger than right box. Is bigger than right box. So we see a dominance of the left part, left tail and left box. So it means it's pushed from the left side. So when you try to draw the graph of it, so you will have something like this. So this part will make a little long. This was short here, short, but it will go up like short, and then it will go like this. So if the left dominant, you say it's left skewed. So left skewed means negative skewed. So you can check the tails and the boxes here, left tail, left box. If you see both dominant or right ones, so it's left skewed. If the right tail, right box dominant, it's right skewed. It has been determined that 10% of the drivers checked do not wear seat belts. If an officer stops 5 drivers, okay, at random, let X be the number of drivers that do not wear seat belt. X, okay, X is the number of, okay, here is a key thing here. X, what is X? The random variable, the number of drivers that do not wear seat belt. X follows a binomial distribution. So this is an important one. So what are the parameters of the distribution? So X has a binomial distribution. We write it this way. And the binomial distribution has N and P. N is the number of trials, and P is the probability of success. But here, what is success? What is trials? Now, when you stop a driver, it has two possibilities. One is like he is wearing the seat belt on, seat belt on, or seat belt off. So it's he didn't wear a seat belt. So this is what's the probability? So we have an empirical probability. It's 10% of the drivers do not wear seat belts. So 10% probability seat belts off, and then 90% probability it's on. Okay, they put on. Now, so this is a binomial experiment. So at each driver here, it becomes a trial. Each driver, a trial. So how many trials we have? 5 drivers. So 5 is 5 stopped, 5 drivers used in this experiment. That means 5 trials. And X is what? X is the number of drivers that do not wear seatbelt on. So the seatbelt on is the success here. No, seatbelt off is success. So because X defines the success here. Success means do not wear seatbelt. So this means seatbelt off. This is the success here, and its probability is 10%. So we will have the number of trials is now it's equal to 5, and it's 5, and the probability of success, which is seatbelt off, which is 10%. So 0.1, it's 10%. What are the possible values of X? X is what? The number of drivers who do not wear seatbelt. So among 5, okay, from 5 drivers. So when you stop 5 drivers, 0 of them can be, 0 of them may be wearing seatbelt, do not wear seatbelt. It means like all of them is wearing the seatbelt. and it means one of them not, maybe two of them not, 3, 4, up to 5. So x values are always from 0 to 5. 5 is the number of trials. What is the probability that 3 of 5 drivers do not wear seat belt? So here the equation, okay, the probability formula is this for the binomial distribution. The probability that x equal to 3 is equal to 5, choose 3, and then the success do not wear seat belt. Okay, how many of them? 3 of them, 0.1 third power times 0.9, which is a complement here. 0.9 is 1 minus 0.1, and to the 5 minus third power. So if you use a calculator, you will get this one 10, this one 0.1 cubed, and then times this one 0.9 squared. So this gives us, okay, if you use a calculator, this will give, and this will give 0.0081. What is the mean and the variance of the number of drivers do not wear seatbelt if the officer stopped 100 drivers? Now, when the number of drivers changes, the number of trials change. Number of trials change now. It will be 100. So now X will have a binomial distribution with 100 trials and with success probability 0.1. So in this case, Ex has this formula as we know. The expected value or the mean of X is equal to n times P, which is 100 times 0.1, which makes 10. So this one here. Now the variance, and for the variance we have a formula. The variance formula is this. The variance of, okay, X, let me remind you, if X has NP, then the variance of X is equal to N times P times Q. N times P times Q, or N times P times 1 minus P, we say. So here in this question, in this choice, N is equal to 100. We know it says 100 drivers stopped. So X has a binomial distribution with 100 and 0.1. And then with the X, the variance of X is equal to N 100 times P, which is 0.1, and times 0.9, which makes just 9. What is the probability that at least one of the drivers do not wear a seat belt? So it means at least one of 5 drivers, at least one. So the probability that X is bigger than or equal to 1. So in this case, okay, we have to calculate Px equal to 2, 1, 2, 3, and up to x equal to 5. But this will take a long time because we have to use the rule like this. I mean, this rule here, the probability rule, the probability formula. Now, instead of this, I mean, we will go with the shortcut. The shortcut is 1 minus the probability x equal to 0. And then it means, okay, it's 1 minus the probability 0 is n choose 5 choose 0, and 0.1 to the 0th power times 0.9 to the 5th power. So you will get 1 minus 0.9 to the 5th power. So this will be a number here. Okay, the answer is, I think this is enough, but you can use a calculator to find it. A large group of students took the final exam in Statistics 132. The final exam grades have a mean of 69 and a standard deviation of 10. Assume that the distribution of final exam grades can be approximated by a normal distribution. So answer the following questions. Now, let's try to understand the question. What is given in the question? The final exam grades have a mean of 69, so this is important. Mean is 69 and a standard deviation of 10. What's the variable now? What has the standard deviation and mean? So it's the final exam grade. So you can say here X is the final exam grades. Final exam grade. And now the mean here is 69, so it corresponds to mu, and standard deviation becomes 10. Now, and it says it has a normal distribution approximated by normal distribution. What is approximated by normal distribution? The distribution of an exam grade. So it will be, then you can say this is normally distributed with mu 69 and standard deviation 10. Okay, these are the ones given to us. Now, find the value of z corresponding to 80. Here we mean 80, the final grade 80. So what I mean here is x equal to 80. Now, there's a conversion formula between the z. So z is the z-score, and the relation between x and z is this. Z is equal to x minus mu over sigma. So just write this one now as z equal to x is 80 minus mu, which is 69, divided by sigma. Sigma is 10 here. So this will be just 1.1. Now, when it comes to z corresponding to 60 here, we mean x equal to 60. So it will be just the same thing. 60 minus 69 divided by 10, which is negative 0.9. Now, what proportion of students scored higher than 80? Proportion means the percentage, or you can write the same thing as the probability that a student get more than 80. Now, in both cases, okay, it's asking the percentage of the data for the exam scores higher than 80. So we can write the exam scores. What is the percentage or the probability that X is bigger than 80? The final exam scores, or when you pick an exam score, it's more than 80. Now, to solve this one, you have to convert. Okay, you have to convert this problem to z, because when you convert the problem to z now, we'll change it to z. Okay, x automatically becomes z, and then 80. So what's the conversion formula? The conversion formula is this. So we already converted this one. It's 1.1. So z-score, the corresponding z-score will be 80, 1.1. So then this becomes now, this is equal to z bigger than 1.1. Now, since we have z, we can use the table. Okay, this table here will be provided to you, will be given to you. So this will be attached to your question sheets. So this will be provided to you, so you don't have to memorize, or you don't have to bring it with you, because it will be attached to your papers. Now, z bigger than 1.1. So here the important thing is z is bigger than 1.1. So you cannot directly use the table here. So to use the table, the table always gives these values, z less than a number here. The table always answers this, okay? But we don't have this bigger than. So in this case, what we do here is we say, we look at the complement of this. This is 1 minus z less than 1.1. So it means this one, not this one, means less than. Okay, so we use the complement of this. So this will be equal to 1 minus. Okay, what is this? We can use the table now. So how do you use the table? It's we divide. Okay, put 0 here. after the first decimal, and then you have to, okay, you choose this one 1.1, and you, for this one, you write 0.00. And please check lecture 12 for this, and check lecture 12 too for the details, and we have plenty of exercise there, examples. Now we find 1.1 here, and then 0.0, it's here, so you find the corresponding value, which is 0.8643, and then when you subtract, you will get 0.1357. So now you can write this one as, okay, this is the answer. The answer is 0.1357. So please show this, okay? Please show your work. Show your work. We want to see this. I mean, if you get this one, it's also okay, but the problem is, like, if this is wrong, then we want to see your work so that we can give you some credit. I mean, if you are doing something correct. Otherwise, if you don't show how you got it, and your result is wrong, then you will not be able to get a point. So this is the bad thing about just writing the solution. I mean, just writing the answer, final answer. Now we have the same type question here, the same type. What proportion of the students failed the test? It's almost same question here. The failing the test criteria is scoring less than 60. So the question comes here: the probability that X is less than 60. Now we will convert this one to. Okay, let's do the conversion here. This is equal to the probability. Okay, we have to change this Z, and 60. Okay, this doesn't change the direction here. 60, the Z score for the 60 is negative 0.9. Okay, the good thing here is this one here. This one is less than, Z is less than, so you can use the table here. You can directly use the table. So if you have less than Z, less than something, you can use the table directly. You don't have to do the complement. So then negative 0.9, where is it? It's negative 0.9. Okay, it will give you 0.9. You can write it two components here. 0 here will be 0, 0. So because always Z has two components, this one and this one here, the column, the first column and the first row, and the negative 0.9. Here, by the way, you will have negative and you will have positive tables separately. I mean, we will have two papers, but I don't have space, so I put them here together. And it will be then, if you look at here, this one and this one, it makes 0.1841 will be negative 0.1841. So I will write this here. This is then 0.1841. Now let's come to the last one here. The last one here, what's the proportion of the students? Okay, what proportion of the students scored between 60 and 80? So the question now is asking what proportion is 60 and 80. It means like they did. Okay, X is between 60 and 80. Now you have to change this one to Z. Okay, X becomes Z automatically, and the direction of the equalities does not change. But 60 and 80, 60 and 80, they become the Z values 1.1 and negative 0.9. So this will be negative 0.9, and this will be 1.1. And let's remember how to deal with an interval here and such inequality. Okay, you have to write this one first. This one, Z is less than 1.1 minus, and this one becomes, okay, with this minus, we change this direction, and this direction will give us Z less than negative 0.9. We have to, okay, this is the rule. we have to write z always less than a number so that we can use a table here. Okay, what is the area for this? This is, I mean, you can, okay, look, 0, 0, and 1, 1, so it makes 0.8643 minus negative 0.9. For negative 0.9, we have, this is negative 0.9 clearly, so this is corresponding to these two values, and 0. Okay, if you have difficulty in using this first row and first column, please check out the examples in the slides. We have plenty of exercises. Please look at them and you'll get it. And the answer will be, the final answer will be 0.6802. I recommend again, write the show your work, please, because if you write the result and this is wrong, then you will not get credit. So it's even, I mean, you have to show, I mean, please show us what you know so that even the result is bad, I mean, we can try to give you some credit for what you learned, I mean, what you know. Okay. And I think that's it, 0.6802. Let's write it here and let's finish it. 0.6802. The following information regarding a dependent variable y and independent variable x is provided. Compute the correlation coefficient for the data. Now, correlation, first I want to write the correlation coefficient formula. Okay. Now, I want to remind you this formula here will be provided to you in the exam. In the last page of the exam paper, it will be attached to your exam paper, so you can use this formula sheet. So this one will be attached to your exam paper. Now, let's do it. Okay, what is n? It's 6 times this one here, 148, and minus the sum of x, 22, and then the sum of y, it's 34, divided by square root of n times x squared. This is 6 times x squared, 104, minus sum of x squared, 22 squared, square root, 6 times the sum of y squared, it's 222, minus the sum of y is 34 squared. And we will get 0.89. So this will be 0.89. And describe the linear relationship between the dependent and independent variables, strength and the direction. So here R is positive, 0.89. So first, since it's positive, we say it's a positive. And 89 is, I think this is strong, positive, strong. You know, here, check the slides in lecture 13. There's a scale for it. So if it is close to 1, it's becoming strong. If it is close to 1 or minus 1, it's strong. But if it is plus, it's positive. it's a positive, strong, linear relationship or linear, yeah, relationship or correlation. Find the equation of the regression line. So in order to write the equation of the line here, you have to find the y-intercept and the slope for the regression line. Okay, I think it's D. Okay, so we are doing C. The formula for B, okay, for B is the slope. And if you remember, this will be, I mean, you don't have to memorize it because we will provide this one for you. And A will be the X bar, no, Y bar, which is Y bar minus A times X bar. Sorry, it's B, which is, this is the sum of X divided by N minus B times, sorry, Y minus sum of X, not squared, divided by N here. Now, these will be also will be given to you in the exam. Now let's use the formulas here. Will be then B will be, okay, since B is here, so I will write it here. N times xy, 6 times sum of xy, which is 148, minus sum of x times sum of y, this is 22 times 34, divided by n, which is 6 times x squared, 104, minus sum of x squared, 22 squared. Okay, let's calculate. So here we will get B as 1. Now let's look at y hat B. Okay, this we will now find A. By the way, this is the slope here. B, the B is always called this is slope. By the way, what we got here is a slope. Now A, we'll have to use this rule here. This is A is the sum of y. This is 34 divided by n, which is 6, minus. Now we know B is 1. Okay, times the sum of x, which is 22 divided by 6. So if you do this calculation, you will end up with 12 over 6, which is 2. Okay. Now we got this one, and this is, you call it y-intercept. Y-intercept. Anyway. And then since we have these two numbers here, we can write the equation now. The regression equation, or the equation of the regression line, is always y is equal to a plus bx, which is now y equal to a is 2 and b is 1 times x, so it will be 2 plus x. Now predict the value of y when x is equal to 5. So it will be when x equal to 5, what is y? You can use this one here, this regression line, to predict it, line equation. So it will be y is equal to 2 plus 5 here, because x here 5, so you have to put here 5, so it will be 7. So y should be equal to 7. I mean, the predicted value of y. And I think that's it. Thanks for watching.